Hello and welcome. Today we're going to show how the contrast solution, in particular the contrast graph, can really help organizations quickly detect and contain attacks and also prioritize vulnerabilities that should be remediated in order to reduce overall risk. You'll see that the contrast graph provides all defenders, SOC analysts and engineers, developers and AppSec professionals with the information they need before an attack, during an attack, and after an attack that ultimately will increase the velocity of their work. So what I'm going to do is actually commit an attack here, actually attack this vulnerability. I have a Docker container, a little local environment where I'm running the app and just executing an attack off screen. And what you're going to see essentially is how the system behaves to this new information that has been sent from the agents that are running this environment into our contrast graph. If I start with the incidents dashboard, you'll see right away this went from an 8.7 to an 8.9. And in fact, a brand new incident was created just 8 seconds ago. So again, this happened in real time. And similarly, if I looked at that issue that was a 9.1, this is now bumped up to a 10. It needs to be remediated. From a developer or from a SOC perspective, the typical thing would be to go in, observe what's going on. By the way, for the SOC person, sees that this attack is actually targeting an area where we have a known vulnerability. So this helps them triage what to actually work on first. So this is pretty bad. A typical workflow would be that I would assign it to myself, and that I'd run it to ground. And in this case, it's an SQL injection, so I would block the IP. Just do block IP using the contrast solution. So I would do that. And if I go back to my screen, you'll notice that incident's now closed out. It's no longer open. But interestingly, our score has not changed. And this is a specific design choice we made because this is really just, anything, if we all know, once a vulnerability has been discovered and successfully exploited, the threat actor will be back. So we make the assumption that until the vulnerability is remediated, it's still a risk for the company. That's why we leave this at an 8.9. And as a developer, I would go in and I would see, oh, look at this. This has an attack associated with it. This pops right to the remediation, top of the remediation queue of things to be fixed. And of course, we've integrated our remediation guidance, our AI-based remediation guidance, so we get localized suggestions for the developer for their framework on how to resolve it. But in our model, I'm going to go ahead and assume that I remediated and tested the vulnerability, and then I'm going to close that out. And then at that point, you see that in fact our score has dropped back down even to lower than it was when we started because we fixed a vulnerability that did exist in the system. So just to wrap up, hopefully that shows you how everything is tied together and enabled by the contrast graph. Each person in the process here has different views, but they're all fundamentally the same flaw. And the product has really provided each defender what they need to help them increase their velocity in containing and fixing both attacks and vulnerabilities.